In this video, I will discuss the rules for drawing resonance structure. The first rule is to avoid breaking single or sigma bond as we draw resonance structure, because breaking sigma bond changes the connectivity of the atom and therefore changing the identity of the chemical compound, and that would then be a chemical reaction but no longer resonance structure. And so therefore avoid breaking the sigma or the single bond. So for an example, if we were to have something like this, do not draw this kind of arrow right here. So this arrow right here means that the single bond between these two carbon right here are being broken, and now the electron will then be donated into this bond to convert this single bond right here into a double bond. But what we're doing right here is that we are breaking the sigma bond, and that is a violation, because again this will be a chemical reaction but not resonance structure anymore. And if we were to follow this arrow right here, then this is what we'll be getting. And rule number 2, never exceed an octet for second row element. Element on the second row cannot exceed octet. And the types of element on the second row that we will be discussing or focusing here in organic chemistry are carbon, nitrogen, oxygen, and fluorine. So this element right here can only have a maximum of 8 valent electrons on them, but no more than 8 valent electrons surrounding them, or basically they cannot exceed octet. So do not draw arrow in which that this element right here will be exceeding octet. For an example, this will be a bad arrow right here to draw, because the meaning of this is that now the electron from this oxygen, going from this oxygen atom, is donated into the bond between this oxygen and this carbon. And effectively what this will be doing is that we are taking a lone pair and changing this into a bond pair between these two atoms. And then that then give electron to this carbon right here. If we were to follow this arrow, then the product of what we created will be the following. And now we can see this carbon right here will now have 5 bonds on it, or basically 10 electrons total. And carbon cannot exceed octet. It can only have a maximum of 8 electrons but not 10. So therefore this would be a wrong arrow to draw. And another example, same thing over here. When we take this will be a bad arrow to draw, because this also is again taking a lone pair of electron of this oxygen and converting this into a bond pair between the oxygen and the nitrogen. And following this arrow, we would have the following. And if we were to now count electrons, then now this nitrogen right here would have 10 electrons surrounding it. And nitrogen cannot exceed octet. So therefore, this would be a wrong arrow to draw. And this last example, the same thing go for this one. So this would be a bad arrow to draw, because by doing that, we will be creating this structure. And now here in this case right here, so this would then be negative. Yes, so I forgot to put a negative charge in all of this. But now, this oxygen right here will then now have 10 electrons surrounding this. And again, oxygen cannot exceed octet. So that would be a bad arrow to draw. Now, element on the second row cannot exceed octet. However, element on the third rows or below can exceed octet. So for an example, if we were to now have this molecule right here, so this is basically sulfidic acid, one of the resonance structure of sulfidic acid. And in this case right here, it is possible for us to basically take the lone pair of electron on this oxygen and donate this in to form a double bond between this sulfur and this oxygen. And now, it is possible for us to do that because sulfur can exceed octet. Even when it has a lot of electrons surrounding it, it is not a problem for it because it can exceed octet. So that will then be okay for element on the third row or below. And now please be aware that it is not a violation of this rule right here if second row element have less than an octet of electron. So second row element cannot exceed octet. However, it is okay for it to be under octet or not having 8 electrons surrounding it. It does not be stable. However, it is not a violation or a big serious issue. For an example, when we have this molecule right here, one way to draw resonance structure is by taking the pi electron in this bond and now move this to this oxygen. And when we follow this arrow, this is what we would have. And now it's important that we also put in the lone pair electron as well, or at least be able to see them. But this will be the product of this. So in this case right here, we will then see that this carbon right here does not have an octet of electron because it has only 6 electrons surrounding it. So it's okay. So this is not a stable resonance structure, and we'll discuss the stability of resonance structure later. But now, just take note that this is not stable because the carbon does not have an octet of electron. However, it is not a violation. And now, rule number 3. Use more than one curve error to avoid violating the octet rule. As we draw resonance structure, we basically will come across steps in which that we can simply not stop, but we have to continue on in order to avoid exceeding octet for element that cannot do that. For an example, here in this case right here, when we draw this resonance structure right here, we can take the lone pair electron from this nitrogen and then donate this into this bond. And once we have done that, we cannot stop right here, because if we were to stop it right here, this carbon right here would now be exceeding octet. And carbon cannot exceed octet. And this is why that we cannot stop and draw the resonance structure in between, but we have to continue drawing the next step. And now we can then take the pi electron in this bond and now move it on over to the other carbon. And in the end, the resonance structure for this, the resultant structure would then be the following. And now all of the atom would have an octet of electrons. And again, perhaps maybe it is helpful for me to draw the structure to see why we cannot stop after we draw this first single step, but we have to follow through with another step. So have we followed through and draw out the structure of this step right here, it would have been the following. And as we can see here in this case right here, this carbon right here will have 5 bonds on it, and carbon cannot form 5 bonds. So the minute we move the electron from this lone pair to form a bond here, we have to break the other pi bond immediately in order for this carbon to go back and be an octet again. And lastly, on this last rule right here, keep track of the formal charges. As electrons are moving around when we draw resonance structure, then the electron density will be changing, and the formal charges of the atom would also be changing as well. So it always keep track of the formal charges, because that again is very important in recognizing the electron density of the molecule. So for an example, let's say we start with this structure right here, and when we draw resonance structure by donating first this electron down, and again we cannot stop here at this step, because if we were to stop right here, this carbon right now it has 4 bonds. When we move this electron down, it now will be having 5 bonds. So therefore, it has to break one of the bonds. And now this pi bond right here will be broken, and the electron in this pi bond will then be donated to the other carbon down here. And the resonance structure that will be produced will then be the following. And now, let's now add in formal charges. When we calculate the formal charges, this oxygen now will be positive, and this carbon right here will then be negative. And we don't have to always calculate formal charges all of the time, but it is something that we expect students to be able to recognize easily. And it is quite easy because of the following. When we draw this arrow basically means that this oxygen is given an electron to this carbon right here. So this oxygen initially it start out being neutral. When it give electron to this carbon right here, it will then become positive. And that's why that it should be easy for us to recognize the positive formal charge on this oxygen. And now this arrow means that the pi electrons that now been shared between these two carbon are being broken. And now the electron we then donated to this carbon right here. When this electron in this bond right here is being broken, it can only go either to this carbon or this carbon. And in this case, it is then going to this carbon right here. But again, no other carbon yet. But the next step would then be the electron to either go between these two carbon. And now this carbon right here will be gaining an electron. And this is why we'll be going from neutral to now negative, since it is gaining a pair of electrons. So please do this example right here, and maybe we'll go over some of this example. So take a few minutes to do them. And now let's go over the answer, assuming you have done this already. So when we follow this arrow right here, and so where we take this arrow and we pull this over to this bond right here. Now I will discuss later that this is actually one of the valid arrows to draw resonance structure right here. But if we were to follow this arrow right here, the resultant structure would then be the following. So the meaning of this arrow is the following. The pi electron that's been shared between this atom A and this atom B is being broken. And that electron is now will be shared with, so initially this electron would then go to the carbon B first, and the carbon B then immediately share that electron with the carbon C, since carbon C can still accept electron, accept electrons, and it doesn't have an octet of electron. So basically we're seeing that there are two, this is an arrow that kind of shows two steps all in once. And the pi bond is jumping from the carbon A between carbon A and B to now between B and C. And now let's try B. Following this arrow right here, we will see the following. And again, make sure you use this double-headed arrow right here, because anytime we draw resonance structure, we have to use this double arrow. And this double-headed arrow right here means that the two structures on the left and on the right of this arrow are basically resonance structure. So when we follow through, we'll be able to see that, okay, there will be a double bond that will be produced between these two carbon. And this double bond right here would be broken, and the electron in this pi bond will be going to the nitrogen as a lone pair of electron. So the nitrogen will then have two lone pair of electron on it. And now let's follow through with formal charges as well. So here in this case right here, starting out this carbon is negative. When it give electron to this carbon, it now will become neutral. And when this carbon now give electron to the nitrogen, and this nitrogen right here is gain an electron as a lone pair of electron, this nitrogen will then be going from neutral to now negative. So recognize that how the formal charges overall is not changing. It does that which atom carrying the electron that will be changing in the different resonance structure, but the overall electron density of the molecule need to remain the same, or the overall charge supposed to remain the same. And maybe we'll try another example in here. So for this one right here, following this arrow right here, we will then see a double bond will be formed between these two carbon. And this double bond had now moved over here. And so this will then become a single bond. And now the electron being used here to form a double bond between this carbon and this nitrogen. So overall, the structure of this molecule will be as follows. So again, nothing happened to this double bond, so keep it to remain the same. And now this electron move over here, so we'll be producing a double bond in here. So in this case, what this arrow right here is showing is that the electron is moving from this carbon right here to the other carbon. So this carbon right here losing an electron because initially it has 8 electrons surrounding it, right? And in this pi bond right here, one of the electrons belonging to it. But when this arrow move over, this carbon right here is losing an electron. So therefore, it will then become positive. And that's what we would have. Now the positive charge on this is remaining the same, and this oxygen right here will then become negative. And lastly, for this one, following this arrow right here, we'll be able to see that a double bond will be produced between this carbon and this oxygen. And we have one lone pair of electrons remaining left on this oxygen, and the formal charge will then become positive. As for the oxygen, this pi bond right here, electron in this pi bond would now become another lone pair on this oxygen. So it will then become in negative.